welcome to the Friendly Neighborhood Tutors. This is the Unit 2 review. Alright, let's just jump straight into it. This unit basically deals with defining average and instantaneous rate of change at a point. So this is sort of like what I talked about last unit. Basically, you use 2 points and you find rise over run for average rate of change, right? You just find rise over run between 2 points and you find average rate of change, right? But then for instantaneous rate of change, basically, if you have 2 points and then you take the limit of the slope as they come together, it looks sort of like this, right? Then you can find what the average slope approaches as the distance between them approaches 0. And as the distance approaches 0, it basically becomes 1 point. So you can find the slope from 1 point. This is the definition of what a derivative is in calculus. It's basically just a slope at 1 point. And it's written as f prime a. A derivative is basically like a function that finds the limit of the slope of a function. It's like one of the most useful applications of limits in calculus. 2.2 is all about other notations for derivatives. For a function y equals fx, the notations can be f prime x, y prime, or dy over dx. These all represent derivatives. Also, one point that's pressed in this topic is the derivative of a function at a point is the slope of a tangent line to the function at a point. Basically, the derivative of a function is the slope of that point, basically. Let's go through an example of how to find the derivative of a function. Imagine the function x squared. Try to find the derivative of it at 1. First, we have to write it in limit notation. This means limit as h approaches 0, x plus h squared minus x squared divided by h. If you expand this turns into x squared plus 2xh plus h squared minus x squared over h. If you cancel all the h's, it turns into 2x plus h, and as h approaches 0, so you have the derivative of x squared is 2x, and if you plug in the value 2, you get it's 2, right? So that's how you find the slope of x squared at x equals 1. Don't worry about this if you don't get it right now. It is about to get a whole lot easier. Just wait till you hear 2.5. 2.3 is basically estimating the derivative of a function at a point. It's basically like, instead of giving you the equation, they'll give you like a graph or a table and you just have to estimate the derivative. You can just do rise over run between 2 points. You can also use your calculator to find the derivative of a function at a point. If you just go to the calculator, depending on your calculator model, you could find the derivative of a function at any point. 2.4 is about 2 things. 1, if a function doesn't exist at a point, we can't find the slope, obviously, because if it doesn't exist, how would it even have a slope? 2, even if the point exists in fx, it doesn't mean that it's always differentiable, or you can always find the slope at that point. You may ask, how is that possible? If it exists, shouldn't there be a slope? Well, imagine y equals the absolute value of x. In its positive values, its slope is 1. In negative values, its slope is negative 1, right? But then what if you try to find the slope at 0, right? It's undefined because it's not like fluid. It's 1 at one point and it's negative 1 at another point. So at 0, there's just nothing there. The point at 0 exists. The function equals 0, but the slope is undefined. 2.5 is the beginning of where we start to speedrun taking derivatives, right? You don't always have to go through the whole definition of limits to find the derivative of every function. You don't need to expand everything and then condense it again. There's a lot of patterns we can use to find derivatives faster. 2.5 is about the power. Basically, if you have a variable raised to the power n, then the derivative is equal to n times x to the n minus 1. Like, you just take the exponent and you bring it down, and then you keep an exponent that's 1 less. So the derivative of x squared, x to the 2, is equal to 2 times x to the 2 minus 1, which is 2 to the x to the 1. Told you, it gets way easier. Okay. I know I said it would get easier, but this next bit is gonna hurt me and you both. 2.6 is about a few more rules. C times f of x, a constant, times c of x. F of x turns into c times f prime x. Example, 2 times x squared the derivative of that is 2 times the derivative of 2x, which is 2 times 2x, right? F of x plus or minus g of x, if you take the derivative of that, it turns into the derivative of f prime x plus or minus g prime x, right? For example, if you try to find the derivative of x squared plus x, the derivative of that is 2x plus 1. You just derive each part and then you add them. You can combine these rules and the power rule to find the derivative of polynomials like I did above. Okay. 2.7 is about sine x and cosine x, e to the x and ln x. Right? So basically, you have to memorize some of these trig functions and their derivatives because the actual explanation is really unwieldy and it's not really practical to learn in this course, but feel free to look that up on your own. Basically, you need to memorize the derivative of sine x is cosine x, derivative of cosine x is negative sine x, derivative of e to the x is e to the x, the only time that it basically stays the same, and the derivative of ln x is 1 over x. Also, this unit is about connecting the idea of the definition of a derivative to a limit. Basically what we've been doing, right? Like we said, okay, the derivative is basically just what this limit approaches, right? Fx plus h minus fx over x minus h. If you recognize that like you have a function and you have the definition of derivative, you can just solve the limit by just finding a derivative function. Like let's say you have a limit, right, of e to the x plus h minus e to the x divided by x minus h, right? Like, and they just give it to you as a limit. They don't say what's the derivative of e to the x. Well, since they're giving you this, right? Since you know, you can recognize that this is like the definition of a derivative, instead of doing this whole process, you can just find the derivative of e to the x. And as you memorized, or should have, the derivative of e to the x is e to the x. There you go. 2.8 is about the product rule, okay? Basically, if you have two functions that are both differentiable and you multiply them together, like f of x times g of x, the derivative of this product is f prime x times gx plus fx times g prime x. For example, x squared times e to the x, the derivative of that is 2x e to the x plus x squared times e to the x. 2.9 is the quotient rule. This is the most unwieldy rule that we'll learn, probably. That I remember. This is the most unwieldy thing that I remember, okay? So you learn how to multiply two differentiable functions together. So now you have to learn how to divide. Fx divided by gx, if you take if you try to differentiate that, it's equal to, wait for it, f prime x times gx minus g prime x times fx divided by g prime x squared. For example, 2x divided by e to the x turns into 2 times e to the x minus e to the x times 2x, all divided by e to the x squared. Basically, 210 is all about finding derivatives of tangent, cotangent, secant, and cosecant. Okay, basically with all those rules about multiplying and dividing functions and the fact that you memorize the derivative of sine x and cosine x, you should be able to find the derivatives of every other trigonometric function because they're just a combination of sine and cosine multiplied or divided. Right? For a challenge, you can try to figure them out yourselves, but you can just try to memorize these. Here they are. I'll leave them on the thing for like 5-10 seconds. Alright, that's it, folks. Hope you enjoyed it. Feel free to like and subscribe if it was helpful. If it wasn't, put it in the comments on how we can make this better. Thank you for watching. See you next time.